This is an introductory video on Chapter 15. Chapter 15 starts in page 482. It's all about forecasting. Now, in business, forecasting, it's all about predicting the future, right? So, in order to plan activities, in order to plan manufacturing facilities, we need to actually have a forecast. Otherwise, we won't be able to plan. In the sales department, we would like to know how much sales we're going to make next quarter. We're in a manufacturing environment, we're going to want to know how many parts, units we need to produce within the next year so we can allocate resources. Resources are people, money, machinery, equipment, etc. Alright, so I want to review with you basically the topics in Chapter 15, starting in page 484, and let me take prior to us getting into page 484. Really, so then, what is a forecast? Again, a forecast is a prediction. We want to make a prediction based on past behavior, and in business, this is usually done as a time series analysis, and all that it means is that we're going to look at the past. We're going to look at the data in terms of month, and we're going to use that data in order to be able to predict future periods. Now, there are two basic types of forecasting. There's qualitative forecasting, there's a quantitative forecasting. Qualitative forecasting is not the focus of this chapter. You'll see that qualitative forecasting only has like 2 to 3 pages at the end of the chapter, while the remaining of this large chapter is mostly dedicated to quantitative technology. Now, in terms of forecasts, we have long-term forecasts and short-term forecasts. Those you will see in page 484, noted as strategic forecasts and tactical forecasts. You can read that on your own. And also, page 485 addresses the issue of independent versus dependent demand. So, we usually call the end product itself, let's say a camera, that would be the independent demand. Well, dependent demand would be the components for the camera, right? So that's basically the definition. You can read that in page 485. And as I look here, it talks about types of forecasting. Right in the middle of page 486, you'll see that there are 4 basic types of forecasting: qualitative, time series analysis, causal relationships, and simulations. With regards to what we will cover throughout these 2 weeks, we'll basically devote our time to time series analysis. We're not going to spend time explaining causal relationships and simulation, which are also part of a quantitative analysis in forecasting. Now, I would like to draw your attention to bottom part of page 486, Exhibit 15.1, and there's a big heading there that says Components of Demand. We like to say that demand has basically the 6 components. Of those 3 are really important. Those 6 components are the average demand for the period, the trend, the seasonal element, cyclical elements, random variations, and autocorrelation. Let's spend some time talking about at least trend, seasonality, and cyclical elements, as people tend to confuse at least seasonality from cyclical elements. A trend, when you look at Exhibit 15.1 and you see there that there's a red line going upwards, a trend is basically an indication as to how our data is moving. Is it moving upwards? Is it moving downwards? Is it level off? And that's basically a trend. So if you look at data over time in a graph, you'll see that it has some type of trend, or it might not have a trend. Seasonality implies that we would expect something to happen repeatedly every season. For example, you would expect that bathing suits be on high demand around summertime. You would not expect to sell a lot of bathing suits during the month of December. So if we will plot the data for sales of bathing suits across time, we would see that every time that we hit summertime, you would see actually a spike or an increase in the terms in the amount of sales for bathing suits. Cyclical elements are harder to define. Cyclical elements do not necessarily repeat with the same frequency as seasonal elements, right? So you might have seasonality means that every year it happens. It happens at a specific date in a specific time within that year. In cyclical elements, they might be repeated, but not during a single year. Let me give you an example. So if we were working for people that measure earthquakes, right? So earthquakes are not something they don't happen every year. Well, at least in a specific location. Actually, we don't know when earthquakes will happen. Are they cyclical? Yes, we know that earthquakes will happen. When will they happen? When will they happen? Sorry. Well, we still don't have the technology to be able to forecast earthquakes with that type of precision. As we move on, page 488 begins the discussion on time series analysis, and it specifically jumps right into linear regression analysis. I won't explain that here. Hopefully you should be able to see a video where I solve a linear regression problem. You might follow the example in page 489 all the way to page 491. For those of you that think that you're mathematically impaired somewhat, I wouldn't be too concerned. I would advise for you to actually do the problems by hand rather than using an Excel spreadsheet. By hand I mean using a calculator. And you have those calculators that can actually help you with some of the statistics. That's even better. They're relatively cheap in the market. There's a special type of linear regression problem that we call decomposition, and that starts in page 492. And decomposition really is about taking away the seasonal, the cyclical, the trend elements for a specific amount of data. Why is it that we want to do that? I'll explain that later, hopefully. After decomposition, which goes all the way to page 497, we start moving into the other types of time series analysis, namely simple moving average, weighted moving average, that's on page 499, exponential smoothing. We also have exponential smoothing with trend, that's in page 502, and finally in page 504 we'll talk about error. Forecast, and this is something that I want everyone to get from this chapter. A good forecast is not about a complicated or complex methodology. A good forecast actually is that forecast which has the least amount of error, right? I mean, we can do a linear regression or decomposition analysis, which is not complicated, fairly lengthy procedure. And if we're far away from predicting what we want to predict, let's say sales, then it's not a good model at all. I mean, we might as well be using a crystal ball. And if the crystal ball produces better result, then crystal ball will actually be a better method than the linear regression. Well, that might be a little odd example there, but I actually want you to get that the measure for effectiveness, for how good a forecast is really the amount of error that it produces. And often what we do when we do forecasting is that we usually do 2 or 3 methodologies at the same time, and then we compare the error. That which has the least error actually turns out to be the best forecast, regardless or how simple or how complex it might be. Beginning page 507, you see some causal relationship. I would like for you guys to read on that. The book also covers multiple linear regression. We won't be covering multiple linear regression in this chapter. And then finally, pages 509 to 511, they go into talking about the qualitative methodologies. All right, so this is basically an overview of what the chapter covers. I hope you do well. Take care.